Start recording. There you go. All right. So in some of these slides, you guys are going to see a few notes. We're constantly updating them. So just keep that in mind. The idea of this class is it's to make it a real class. If you have a question, just ask it. If you need a better explanation about something, ask for it. If you have a comment, say it. If you have anything in your mind, any experience, anything, just say. The idea is that we are all working together in order to understand this particular topic, and after 1 hour, 1 hour and a half, we're going to walk away with as much knowledge as we can. I'm going to take out these headphones. Can you guys hear me? Guys,
yeah.
Hear me?
Yeah, I can hear you.
Cool.
Yeah.
These headphones are not really comfortable for this. I hope I don't have any echo. All right. So first thing, I'm seeing a few questions on the chat. I can't take that. Sorry, because there are two different screens. So if you guys have a question, just unmute yourself, speak up, and that's basically it. I have seen this one. If we're going to focus on Python 3, we're going to focus on both. We're going to talk about Python 3 and Python 2, because we know that in our experience, Python 3 is probably the best version to work with today. But the truth is that there are still Python 2 installations around. So you guys need to understand how that works also.
एक online class होता, तल मी sign up केलं होतं.
What? Sorry? I think you guys can also mute people. Can you? I need some muting police. If you guys hear background noise, please mute that guy. All right. So Python 2 and Python 3. Again, Python 3 is our preferred version. We know there are still things working on Python 2, and there will be. So we're going to focus on both. We're going to start talking about iterators. Again, any questions, just let me know. The idea of iterators is, of course, to iterate through things. I'm sure you guys have all iterated through, for example, lists or collections while you have been working with Python. And the idea is to build our own objects as iterators, provide the same interface for a user. Like that user is using a list, they can use the same interface to use our objects. The idea of this class we're going to start saying what they are. We're going to try to understand them, and of course write them. That's the focus of this class, start writing good iterators. Before we can write them, we have to understand how these iterators are used, because in how we use the iterators, we're going to have more details about what is going on underneath. I am sure you all guys know how to do a for loop, right? Just iterating through a list. But there are other ways to iterate a list or a collection or any type of iterator. One of them is by using a next function and constructing iterator objects out of that list. I don't know if you guys have already seen this, but when you have a collection, when you have an iterator, you can construct iterator objects, right? That you will be able to use to iterate over, right? So we have one central object, in this case our list, and we will be able to create individual iterators that we're going to use to iterate through that list. These are all independent, isolated objects, okay? We're going to make use of this iterator with the function next, all right? So these are the two things we have to connect. The iter function, as you can see here, and the next function, as you can see here. So we will first, let me go here, we will first build an iterator, as you guys can see in this second line, and then we are going to ask for the next element in that iterator, right? So when we first create this iterator object out of this list, we're going to get the first element in the first next invocation, the second element in the second next invocation, and following that order. So I want you guys now, if you go to the slide number 2, you will have this link. I'm going to send it also through the chat. But I want you guys to start to open this Cloud9 account and start requesting access. So if you will see a button here, a green button, I think, that says request access, right? So request access, I will start running it. See, I have just asked someone. And we're going to focus on the first example, the next function. And what I want to show you guys is how we are constructing different iterators objects. And these objects are all isolated and independent. Whoa. Seems like Cloud9 doesn't like having so many people. So what we're going to do is we're going to construct a few iterators. We're going to ask for elements to them, and we're going to see how these objects are independent, right? So for example, we have constructed 2 iterators, iter2 and iter1 and iter2, right? Or it1 and it2. And I can ask for the next element on each of these iterator objects, right? So in this case, for example, I have do next on the iterator 1 and 1 2 times, so I get the element 1 and 2. You guys can see the result right here. And then what I'm going to do is do the next function, invoke the next function with the iterator 2 for the first time. And of course, what I'm going to get is the first element, right? So as you can see right here. So what we see here is that these iterator objects are all independent, right? And they are isolated. I have just constructed 2 iterators and I can use them independently, and I will see the correct result or the correct order that I'm expecting for each one of these iterators. So we are seeing here, basically when we do a for loop, the for loop is doing the same thing. It's constructing an iterator and it's invoking the next function many times. How many times? Until it reaches the end of the iterator, right? And how does the for loop know when it has reached the end of the iterator? Because when you invoke next on an exhausted iterator, right? On an iterator that doesn't have more elements, what is going to happen, and we can see it right here, is that the iterator will raise a stop iteration exception. It will raise an exception. That's the way that the iterator has to signal to us that the iteration has stopped or that it doesn't have any more elements to give us. So we're going to try it right here. See, we have the first 3 elements here, and I'm going to add one more, sorry, right here, this 4th next invocation. And what you guys are going to see is right here how, whoa. After the 3rd element right here, when I try to invoke it again, a stop iteration exception is raised, right? So this is another way we have to construct and use iterators, right? We have an original object that we want to iterate over, the list, and we have decided not to use a for loop, but we are doing just manually first constructing the iterator and then invoking the next function over and over and over again. Guys, after you select this code, Omar in this case, can you unselect it? Because I think it will not look good for the other guys watching the screenshot. Thank you. Oh, sorry. So again, a different way to use the iterators is with the next method. Basically, guys, when a for loop is invoked, what the for loop is doing is just doing something like, I need the mute police to get someone. So basically, for loop, if we don't have for loop and we want to mimic it, we could do something like can someone try muting the guy that is not muted? You can do it, guys.
It won't let me mute him.
What?
It won't let me mute him.
Oh, maybe because the phone. Who's connected through a phone? 410 was connected. Right. So again, what I'm trying to do here is to show you what the actual for loop is doing inside, right? So it's truly just doing this. For example, we want to do a for loop that does something like for lm in a list, right? Sorry, print lm, print every element in the list. What it's doing, it's just creating an iterator, doing something like a while through, print, sorry, lm equals the next lm in this iterator, id1, printing the element, and listening or waiting for the stop iteration exception to happen. And when this iteration happens, the iterator is signaling us that it has stopped, or there are no more elements to iterate over, and we just break out of the loop, right? So what we have right here is basically the body of the for loop. It's what we have right here, right? We are requesting manually the next element in every new iteration. And of course, we have to remember to construct the iterator object out of the original collection, right? So again, the for loop is basically constructing an iterator and iterating over it with the next function. Super important because we are going to be, when we build our iterators, we will have to raise a stop iteration to signal to someone who is iterating over our object that the iteration has stopped. Okay, so following on, any questions? Oh, cool. So we're going to talk about the iterator interface because it's really important to understand, in order for you guys to never have issues writing iterators, how they work. Basically, when we refer to an interface, it's basically saying we're going to treat our iterators as black boxes, and we're going to talk about how our iterator is invoked, right? How, for example, these are our users, the black box is our iterator, how they are going to use us, right? And what are we going to respond to them, or how are we going to answer to those usage, right? In this case, I'm going to skip over this slide, but basically the way the users will have to use our iterator is through what we have just seen, the iter and the next function, which translate one-to-one to the iter and next methods in our iterator object that we're going to see in a minute, don't worry. And what are we going to, how are we going to answer to our user? Well, basically, of course, we're going to return an element every time they are asking for the element, or we're going to raise a stop iteration when we know that there are no more elements to iterate over, right? So this simple interface, it's what we have to keep. And even though it's simple, there are issues, right? If we don't respect it well enough. For example, if we forget to raise a stop iteration, we will have an infinite loop. So this simple interface, if we respect it, we're going to have good iterators built. And finally, I have this slide because we like to talk about a good example of interfaces and why we should have the iterator, why we should make use of the iterator interface, right? Because it's like I am talking to you about iterators and we're going to talk about generators, and that's the solution, right? Why would you like to learn all these weird methods to construct iterators? And basically, why we need to do it is because we want to have good interfaces for our users. What does that mean? Suppose that you have I don't know, you're constructing a system that retrieves photos from a photo album, right? So when you construct the photo album for your user and your user has to like iterate over the photo album, right? You have I don't know, your user is going to do something like album equals get album, I don't know, maybe it will pass a year, right? And then your user will want to iterate over your photo album. How are you going to do that? Well, if you don't use iterators, you guys can think millions of different ways to do this. You can do something like, I don't know, album.getPhoto. I'm just making this up, right? For example, next photo is going to be this, and the interface that you have with your user is that if next photo is none, so it's going to do something like if next photo is none or not is photo, sorry, not next photo, then it can do something like photo, no photos, right? So you have created a new interface for your user. If your user wants to use this album, she or he will need to go to the documentation of your system to understand how to use your album, right? You're giving new information, you are giving new ways for a user to work. And usually that's something we want to avoid. Our user already knows how to use iterators. Our user has been iterating over lists for years. So what we want to give her is something like, for photo in album, print, I don't know, photo, right? Photo dot, I don't know, URL, right? We want to give them a clear, intuitive, and well-known interface. We don't want this. We don't want custom-made stuff. We want standards. We want to follow standards, and we want to provide those standards for our users. Whoa, the code has been just disappeared. And the best example, to make this quick, the best example for that is just the power system and how you plug things and how you charge things. And I want you guys to move back to the 18th century and think how people used to charge things, how to interact with electricity. And everything was so different. You know, you moved to a new country and everything was different. There were different types or ways to interact with electricity. And think about now, think about the power system in your country, how complex it is. I don't know, thousands of miles of wire interconnected. It's such a complex system. And yet the way you have to interact with that system is super simple, right? You want to charge your phone, you just get your charger, you look up for a socket in the wall, you will just plug it in, and your phone will be magically charged, right? So that's an example of a good interface. It's hiding a really complex system, the power system, with a super simple interface. The interface is just that socket in the wall. And even if you move to a new country, the interface that you will have to charge your phone is the same one, right? If you're in China and you want to charge your phone, what are you going to do? You will probably just look for a wall, try to identify a socket, and maybe the type is different, but the interface remains. It's an intuitive interface. You have moved to a completely different country, and you're looking for the same interface. So again, you have photo album. It's a completely new option for you, but you want to iterate over the photos, and you're looking for the same interface for photo in album, right? That means that it's intuitive for you as a user. So now we're going to start writing iterators, and this is the part we're going to have more fun. I want to show you guys an example of a super simple iterator. We have that same example here. And basically what this iterator does is it will let us start talking about how to construct this iterator. But first, let me run this example. I am constructing an iterator. I want you guys to read this code. I am constructing this iterator, and I am asking for just the first two elements. So I'm running this code, and as you can see, I just get 2 elements, 1. This iterator is a super simple and naive iterator that will just always return the number 1. All right? It's an infinite iterator. This will never stop. If I put this in a for loop, please don't do it. This is going to run forever, right? Because as we saw before, there is no stop iteration. There is no way for the for loop to know that the iteration has stopped. But it's going to be useful for us to understand a few things. First of all, every time someone invokes next, the next function, it's actually invoking our next method inside our iterator. Second thing, Python 2 versus Python 3, the first question we got. In this case, we are defining 2 methods. The next method with 2 underscores before and after the name, and just a next method without underscores. This syntax that you have right here, it's basically writing an alias for this method. So it's something like doing like forwarding the shove of this next to this other method, right? It's just as simple as that. So we need to do this because if we execute this with Python 2, Python will be looking for a next method. And if you invoke this with Python 3, Python will be looking for an underscore next method, right? So we can try this. I have in this console here, I have Python 2 and Python 3. You can actually use it. So, for example, I'm going to wipe out this next method, and I will try to run this example using Python 2. As you can see, this iterator says that there are the object is not of a type of iterator because it doesn't have a next method. If I rename this to next, you can see that it just works fine. If I try to run this with Python 3, sorry, now, it's going to give us the same result. It's saying that this thing that I have here is not an iterator because it doesn't have an underscore next method. If I now change it and I run it again, you guys see that it works. So 2 things. The first, for Python to know that this object is an iterator, it has to have a next method. I'm just saying next method because I don't want to get like either this one or this one. Depending on the version, you have to provide the next method, and Python will understand that this thing is an iterator. Now, depending on what version you are running, you will have to either provide this method or this other method. Or even better, always provide two methods, right? Even though you know that your iterator will be using Python 3, this doesn't hurt. Just provide you with a more robust solution for your iterators. So again, super simple iterator. Every time I invoke the next method, it's returning a new element, the element 1. As you can see, this is just a simple Python class, right? There is nothing fancy here. It's just a Python class that implements two methods, the iter and the next method. So what is an iterator? It's just a Python class that implements the iter and the next method, and that's it. If you're doing these two things right, you have your iterator. As we say that this is a Python class, we could, for example, pass parameters to it. So if we don't want it to always return 1 and we want it to return the word hello, lm to return, we could easily implement it by ourselves. So I could add something, for example, to the init method. By default, I'm going to do 1. And then every time I return something, I will return this lm that I have that was passed when the object was created. So as you guys can see, I have changed now. If I put it back again as it was before, I have the same result as before. So why am I doing this? Because I want you guys to understand that iterators are just regular Python classes, and we can use them as they are regular Python classes, and that's really powerful. We're going to see later why. The other thing that we have is to understand why we have this iter method that seems that we haven't used it really very much. This iter method, and this is just a spoiler because we're going to talk more about this later, is the method that is invoked when we invoke the iter function, right? So when we invoke the iter function from outside the iterator, right here under this line, we are the users of the iterator. When we invoke an iter function, we are basically invoking this iter method. Right now, it's a really naive method. It's not doing too much, but we're going to see how it works in more advanced cases later. The next example we have is right here. You can see it, guys, in this line. We're going to understand why we have the iter function, why we're using the iter function. So basically, I wanted to run it. I'm going to first do something like my iter is going to be an iterator out of the object tic-tac-toe. Let me take this out so you guys can see it better. And then I'm going to just print 2 times the element returned by this iterator. And as you can see, this is the simple iterator that will give us the words tic, tac, and toe. But there are a few interesting things here. The first one is that this iterator is making use of the 2 features that we were still trying to understand. The first one is the stop iteration exception, right? So this is something we talk about, but we have never used. I think it's pretty clear now, but when we want to stop the iteration, when we want to signal, when we want to say that the iterator has been exhausted or that the iteration should stop, we just raise a stop iteration exception. That's the way that, for example, the for loop, and I'm going to run a for loop right here. That's the way that the for loop has, there you go, tic-tac-toe, to understand that the iteration has been stopped. And then we have this iter method that we're going to talk in a second. So, starting with the stop iteration exception. This is something that you guys have to think upfront when you're building your iterator. What is your iterator doing? First of all, is it an infinite iterator or is it a finite iterator? It has a clear start and an end, right? There is a way for this iterator to stop. In this case, we want to print the words tick, tack, and toe. So of course, this thing has an end. Whenever you have reached the word toe, we know that this iteration has stopped. So we can just finish it. How do we finish it? With a stop iteration exception. The second thing we have here is that we have used the init method, right, to set an index that is going to be used during our iteration. So how this thing works is every time I invoke next, let me go back to our previous version, right here, every time I invoke next, I have initialized an index with the value 0, and I will return the element, the word that is in the position equals to this index, and I will just increment this index, right? So let's think about the first time this iterator is, this next function is invoked, right? Index is equals to 0. We can just avoid this part right now. We get a word. In this case, it's the first word, right? Because this index is equals to 0. We increment the index before leaving, and then we just return the word, right? And the second time we invoke the next function, we do the same thing, and the third time, the same thing. What we have here is that before we do anything, we have a criteria to understand that if the iteration has stopped or should stop. What we do is we always have to keep for ourselves a way to keep track of what's the next element that we should feed in, right? Or we should serve to our user. In this case, we do it with the index. And then we have a criteria that's super simple that just checks if the number of elements that I have returned is equals to the length of the list. This is similar. I don't know if you guys have ever worked with recursive functions, but every recursive, the first thing you learn when you are writing recursive functions is to think about a criteria to stop the recursion, right? Think about a stop criteria that will just break you out of the recursive function. In this case, it's the same. Whenever you're writing your iterator, think about that criteria that will make you stop the iteration. When has the iteration been exhausted? That's basically how it works. And then, of course, you have to keep track of the element that you can think about it differently. You can think about the element that you have just returned or the next element to return, but basically you have to keep track of where you are every time the next method is invoked. Any questions? Oh, cool. So let me wrap up this iterators thing before we move forward. And a few things to remember when you're writing your iterators. First of all, that Python 2 versus Python 3 different. For you to have an iterator, you have to have an next method. Which one? Try to always put both, right? Try to provide this alias thing so you can have both Python 2 and Python 3 compatible iterators. Again, think about the stop iteration, sorry. Think about when your iterator should stop, right? Think that up front so you don't have infinite loops. Oh, we forgot to talk about the iter method. I'm just going to talk about that later. And finally, think about the ways that your iterator can be used and if you're doing it right? So when you write your iterator, don't just think about writing a simple for loop, but also think about people using it with a next method, for example. Are you doing everything correctly with just the next method being invoked? I had forgotten to talk about this iter method. We're going to talk about this later. But basically, it's in the following way. I'm going to first comment this thing out. I'm going to go back to this iterator. So I removed the code, but basically, we were constructing two iterators. Invoking the iter method 2 times on the first iterator and invoking the iter method, the next method on the second iterator just 1 time. And we knew that these 2 things were isolated. These 2 iterator objects were isolated. That's the reason we have this iter function. It's the way we have to construct iterators. So what is going to happen here is that I have changed this, and now I will try to do something similar as what I did here, and I will see that these 2 iterators that I'm going to build are not isolated. As you guys can see, the first time that I invoke the next function on the iterator 2, I am expecting to get, of course, the word tick, because I have constructed a new iterator. And as we said, these 2 things should be isolated. But as when the iter function is invoking our iter method, we're just returning the same object. So these 2 things are seeing the same object, and that means that it's basically the same object being pointed out by 2 different variables. So IT1 and IT2 are just pointing to the same iterator, and that means that these 2 iterators are not isolated. All right? So the iter function will let us change how we how we isolate different iterators, and we have different ways to do them. And before I move forward, I want to say these ways we have to think about the iterators that we build out of our iterator object are things that you have to think based on the case that you're working, and there is no right or wrong answer, right? So, for example, if I want this thing to be completely different and isolated objects, what I am going to use is actually return new objects when you are asking for an iter method, right? So for example, I'm going to return 2 different objects. I'm going to return a new object every time you invoke the iter method. So now the results of these and the results of these are completely different objects. If I run these, I should see the same result, the results that I'm expecting. So the first time I invoke the iter method, the next method on this second iterator, I have the first result that I'm expecting. Or the other way that I have is similar to what I had before. I can rewind this iterator. So in this case, if I invoke this, I see, whoa. Something is not right. Oh, no, because I have to construct it, sorry. I have to construct the iterator after I have reached these two. There you go. See, I have the first word as I'm expecting. But again, this is the same object. So these two iterators that I'm constructing are not completely isolated. The way I invoke these things will have a difference based on if this is first, on that's last, you know, so they are not completely independent and isolated. And that might be fine, right? Depending on the case that you have, if you either rewind the iterator as I am doing right here, or you construct a new object as we were doing before, or you just return the same object, that has a different semantic meaning, and that's fine. You have to think about it. So for example, if we have an iterator that creates random passwords, we maybe want to just return self because we don't want it. If you have already walked through these iterations, we don't want you to go again through the same password that we had before because it might be a security breach. I don't know, I'm just making it up. But what I want you guys to understand is that there might be a semantic difference between each of the ways that we have seen to reset or return new iterators, right? So the first thing we can do is just return the same object. The second thing is rewinding the iterator, so it's the same object, but I am changing back to state as it was before, right? This has other meanings because now this iter object has been changed. And the final way, and maybe the most preferred one, if it makes sense, again, is just returning a completely new object that is isolated from the other iterators. Questions?
When you rewind the second iterator, does the first iterator get affected?
Yes, exactly. It's the same object. Okay. We can actually try it. For example, we construct the first iterator, we iterate 2 times, we then construct other iterator, and now we call back again the first iterator. See, we're getting tick again. When we have already done these two times and we're expecting to get it the third object, we're getting back the first one because this iterator is not completely isolated. It's the same object and it's modifying our first iterator. This makes sense if you're, instead of doing next, you're using for loops. So for example, if I do, let's comment all this out. If I do something like for lm print word, I was using the word word. And let me take this out, right? Without any resetting, without anything, just this way. If I have 2 for loops, the second loop will never be run because the index is already 3 or 2 actually, yeah, 3, and the iteration has been stopped. But if I want to do this, I can just reset the iterator the next time you ask for it, right here. And of course now it works as expected, but it's the same object. Right? So that's what I was saying in this slide, that you should think about the ways an iterator can be used, because maybe if you're just trying this thing makes complete sense and it works as expected. But when you change the way you use your iterator to this way, then it has maybe a different meaning, or even this can mean that your iterator is bugged, right? You have bug because you haven't thought about this use case. So again, 3 ways: resetting it, returning a new object, or just returning the same object without any modifications. 3 different ways to make use of the iter function. Each one of them has a different semantic meaning. And again, there is no right or wrong. There is just what works or what should happen for your own iterator case. Questions? No? Okay, so before we jump to generators, we're going to work with a more complex example of an iterator. I have a database, right, with Pokemon, as this Pokemon Go fever we have. It has just one table, which is a simple database, just one table. It has some testing data, right? It has 3 Pokemon. And what we want to build is an iterator. So we're going to do something like for Pokemon in Pokemon iterator, print, and we can do something like Pokemon.name, right? We have a custom object, as I was telling you, the photo album, in this case, the Pokemon iterator, and we want to construct an iterator for it so we have a clear and intuitive interface. Right here, you guys have the way to access this database, right? So we import SQLite3, we connect to the database, we then create a cursor, and then we execute this query. Can you Nasab unhighlight this code right here? Thank you. So every time you do fetch 1, you get a new element. So let me run this quickly. See, you have the first data right here is Charmander. Then we can do, for example, the second result, right? So basically, we want to change this code that it's already working and put it behind a clear, intuitive iterator interface. So it's your turn. Who wants to work? Who want to do it? Someone, of course, that has already accessed Cloud9. Guys? Come on, someone has to take a try. I have all day, I can wait. Guys? No one?
Okay, what's the question again?
We want to build an iterator for this data that it's already in the database. So we want to do something like this is what we need for Pokemon in Poke Iterator. Right? So this is the way we have to access the database, and we want to put it behind this clear interface. We want to build an iterator that anytime we do next, it's basically returning the data in the database. No one?
You would just put next. I'm sorry, in the next method, you would put your cexecute. No, I'm sorry. Your cursor, your fetch one to return.
Do you not do it? Type it?
I can get the screen.
What? Sorry?
You want me to tell you what it is, or?
Oh, I thought you were typing.
Oh, I'm not. Someone else is typing.
All right. So David has taken the lead. Let's see what David has.
I don't know if I'm muted or not. I think I'm not.
What?
I think you can hear me.
Yeah.
Yes.
So we guys just watch and help. We're doing pair programming.
Let's see how this goes.
Awesome. I think you want to put that select star in the init.
Oh, good point.
Good one.
Excellent point.
Yep. Perfect.
And that will give us, let's see, the cursor object will have that, so we can still get. So the init has the SQLite connection and the SQL command. The next command gets one of the objects and returns it, and the iter method returns this object itself so it can get created.
You could also close the connection in the init if you want to.
Yeah, I guess we could.
You don't have to init. Yeah, that leaves a.
When should the iteration stop?
I mean, you have the list once you've selected the list, you have it. Right?
I guess we can do.
You don't have to. That's just being cool.
This won't catch an actual SQL error, but what was the?
Actually, that's something I should have told you before. The SQLite, the way SQLite works is that when it doesn't have any more results, I can show it to you like right here. It will give you a none back. See?
Okay.
So you're in the right track, but it's not an exception, but the none.
Let's see here. So we can still get the object and then test to see if we actually get something, then we can return it. Otherwise, raise the exception.
Yep, you have a couple of syntactic issues with the if is missing a colon.
Yep, there we go. Yep, and so is the else. No, the else has it.
And check the rest word.
The what? Oh, yeah.
Because there you go.
There we go.
Finally, you can this is a raise. You want to raise the exception instead of
Yep, I agree.
So let's see if this works. I'm going to comment out all this code. We're going to, oh, forgot to move this up. So global name con is not defined.
Oh, there we go.
Save it running. Oh, yeah. So let me just take this out so you guys see that the thing works as expected. It's returning each one of these elements. So good job. That's basically the way to do it. A few things. First of all, this, for example, is not needed. Yes, because this seems like a super stupid thing, but when you're nesting more levels, it's like it gets harder to read. And something else is that, for example, if I change this code and I do something like this, I am putting my condition at the top level of the next method. And this, when you have a more complex iterator and you can just read the next method and clearly see where is the condition, where is the real work done, changes a lot. Of course, this is a matter of taste. You can just keep your code as looks better for you. That's just, again, a matter of taste. But it was just a few additions that I wanted to know. A few other things. We could easily have a helping object class. So for example, I could have something like class Pokemon. What else do we have? So main. Something like these. And when you return your object, you could wrap it up with a helping. Oh, this is 1 and 2. With like an auxiliary or helper class. Why would you do this? Because in this way, you're giving your user the same interface. This should work now. See. You are giving your user, you're ensuring your user the same interface. If you ever want to change for example, what database you have or the structure in your database, the interface that you're returning to your user will remain the same, right? So again, think about the power system in your country. I don't know, around the corner, they changed the voltage from 110 to 10,000 with a transformer or something. You don't see that. They are abstracting that for you. So when we write iterators, something that we usually do is try to completely abstract how they are going to be used for a user, providing, again, an intuitive interface and something that we can control, right? If we are just returning whatever the database is returning, if someone changes the database, we are no longer returning the same thing for a user. If someone, for example, adds other field here, we will just have to change our code, and now the field type is no longer the third one or the index 2, it's now the fourth one. But for a user, the interface will remain the same. So that's something important when we're writing it. Something else that we haven't thought about it. Who did this code? David?
Yep.
How do you think, David, again, because it's just a matter of taste or design, your own design, this iterator should work with regards of the iter method? What should happen if I, for example, put 2 consecutive iterators with the same object? Let me get these. If I construct this object and I try to iterate it 2 times, what should happen here? In this case, as you're returning the same object, there is no second iteration. What do you think, or what's your?
We've reached the end. It's the same. They're linked right now. We did one of the methods that you showed us before, but if we changed the return for the iter to be a new pokey iterator, we would now end up with separate thingamajigs.
Yeah, that's a good idea. But again, it's your design. It depends on how you're thinking about it. Can we, for example, make these more powerful? For example, if I do something like database name, and I want to Pokemon DB, and I want to, let's just say we want to do these. How does your code change?
We would have to change the connection command to grab the database name that you just created. Is that what you called it?
What? Sorry?
Yeah.
And what else?
I'm not sure.
Something important is that you should construct it right here.
Oh, yep.
In the same way that your original object was constructed, so you're not returning something different for your user.
And maybe a default just in case.
Yeah, but that should go in the init method right here.
Oh yes, that's copied.
Yeah.
Cursor control.
There you go. And of course, we need to, for reference, I'm going to add this here. Cool. Something else, guys, that you could do is, for example, try to add different, for example, something like query. You could do something like name equals char, something like that. So when you create it, you could put a where clause based on the name. If a where clause was passed, you know. But if you guys want to keep working on an example like this, it will help you like improve the final work. So let me show you really quickly. During class, we do pretty I don't know if complicated, but a good example of a complex iterator. And you are free to grab this repo. I'm going to send it to you through the chat. And basically, we use this open Star Wars API, right? That it's basically an API that returns data about the Star Wars movies, and it will give you, when you, for example, request for all the people in the movies, it will return a list of results, right, of all these movies. The interesting thing about this API is that it returns, even though it has 87 results for /people, when you just ask for /people, it will give you the first 10 results. And the other 77 are in several following pages. So if you want to get the next page, for example, get the 11th people in these, the 11th person in this API, you gotta request the second page. Right? So first we have Luke, and now we have Anakin. This is the 11th guy in the movies. So this project right here, it's something we do in class. You guys can see a few pull requests still there if you want to take a look at how to do it. It's basically hiding a complex API with pagination and all that under an interface similar to right? And we should get the 87 results with this simple iterator. So the next method here is checking constantly if it needs to fetch the second page or the third page, if it still has pages to fetch. You know, it's a more complex example. I invite you guys to take a look and to try to do it by yourself, because if you want to really nail down iterators, this is the way to go. And it's basically how most SDKs for Python. So for example, you have the Facebook API and you have an SDK to use with Python. So you wanna, I don't know, get all your posts from Facebook with that library. It will probably just use an iterator like these ones. Did I send the link? Yeah. Okay. So, iterators. Any other questions? We're going to jump to generators.
I just had a quick question.
Yep.
In the init method, how do you determine what goes in the parentheses and what doesn't for the iterator?
Well, it's just, again, design. You know, for example, what I see here is that what we had before was these looked really hard-coded, right? Like the database name here, so maybe it's better to pass the database name. Something else, for example, is the name of the table. So it's just, you have to figure out what makes sense to put in the init method. How, as more methods are included here, you have more, how to say, more possibilities, or it's more robust, your iterator, for changes, right? It's more flexible. But it's just a matter of design, how you're going to design your own iterator.
Okay, thank you.
You're welcome. So, generators. Let me tell you the truth about, let me take this out, it's going to break. About generators. Generators are just cheating examples, cheating ways to construct or easy iterators, right? A generator is just a simple way we have to construct iterators. So let's look to things, no, not this one, side by side. These two things, line 1 to 11 here, is doing basically the same thing as this thing right here, line 1 to 3. This is generator, and this is an iterator, and they're doing the same thing. A generator is just a simple way for us to construct iterators. You will see, or you will identify a generator because it has the yield keyword, right? And what happens here, it's basically, I am getting pretty much the same code as I have with this iterator, right? Just doing next, next, next. And I am just getting numbers 1, 1, 1 every time and invoke it. I can even pass the lm to get, right? And it's the same thing as we had right here. How does it work? First thing, if it has a yield keyword inside, it's a generator, not just for us, it's also a generator for Python. It will treat this function specially. It's not just a simple function for Python. For example, I'm going to show you something. I'm going to put a random print statement here. I'm going to execute this function. And as I'm executing this function, of course, I'm expecting this thing to get executed, but it will not happen. See, there is nothing printed on string. Why is that? Because as Python is noticing this yield keyword right here, it's understanding that this function is not just a regular function, it's a generator, and it doesn't have the same semantics of a general function. This code will be executed the first time you invoke a next method, the next function over it. So if I do this, you guys can see that I have the hello world print statement from here, and I also have the first element that I'm getting. So this works in this way. When Python realizes that you're executing a function that it's a generator, it will not run it. It will stop right here in the first line, and it will just hold the execution there. The next time you invoke a next method, it will resume the execution. It will print this line, go this line, get to a yield statement. It will give you back this element, and it will hold right here. It will hold the iteration right there. Whenever you ask for the next element, it will then resume the iteration from here, and it will keep working with this function. So for example, if I put another print statement here, and I have just one next, exactly what I told you. Let's start first with this one. The first stopping point that a generator has is when it's first constructed, right here. It's constructed, Python has evaluated this whole block, it realizes it's a generator, it's not executing it, it's just waiting there. Whenever you invoke the first next, it will resume the iteration, the execution. It will go until you have the first yield statement. It will give you back this result, and it will wait for the next one here. So we get the result, but this line was never executed. If I put now this one, you see how it's now executed. It go back to this place while true. It is an infinite loop, so it's going to go through these over and 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 over again. Make sense? We're going to take a quick look at how to do the same thing with a tic-tac-toe. So in this case, we have a generator that in our previous iterator, it had a condition, right? So we were working on each of these words, right? Keeping an index, and when we noticed that the index that we have already served all the words that we have in our original list, the iteration was stopping. In this case, the iteration stops whenever the function stops, as simple as that. So I'm going to run this, and as you can see, this is the same result that we have right here, but now with a generator. As you can see, it's a way simpler implementation of an iteration, right? Of an iterator. It's easier to write maybe a function than writing all this class with all these things. In this case, we're even leveraging on the for loop for this collection, right? So it's like the only iterator in this collection is being used for us for this yield method. Make sense, guys? Any questions? Nope. There is something you might want to take a look. The yield from Python 3. This is just a Python 3 thing. It's not in Python 2. Whoop. So basically we could put, and it's a way to generation delegation, and it's basically a way to rewrite these in a better way. Instead of just looping through it, you can just do something like yield from words, but this is going to work just with Python 3. So let me run this with Python 3. What version of Python do we have? Sorry, guys. See, it's now working. This was new in Python 3. Maybe, I don't know why it wasn't working. 3. Iterator examples. 5. It's working. Anyway, it's the delegation feature. It's only present in Python 3. Really useful, but you are fixing yourself to Python 3 if you use this. Questions? No? Cool. So to wrap up, we have the iterators. If you're writing, guys, iterators, just make sure you are nailing down the stop iteration part, right? Thinking about when the iteration should stop, and think about the iter method, if you should reset or rewind your iterator, if you should return a completely new object, or if you should do pretty much nothing. All right, so think about it too. Those are the two most important things to think about when writing iterators. Any other questions in general about iterators or generators? I am wrapping up. Nope. Cool. So again, the idea of iterators is to provide a good interface for your users. Just writing an iterator, it might take more work for you, but the users that are actually using your object will be grateful about it because they will just do a for loop, simple, intuitive. Guys, again, we're going to keep doing these classes. It helps us. To be honest, it helps us write our own material, and it's also helping the community. That's the most important thing. So if you want to browse the projects that I have in that repo that I have just sent you, all those are all projects we do during class. And there are pull requests there with solutions, so you guys might find that helpful. Again, if you are interested in our course, just browse it, rmotr.com/PYP in this case. You're invited to apply. We are opening a new batch in a few days, August 22nd. So thank you all for being here. I know it's late, it's early, sorry, it's early. I know Brian is sleepy. But anyway, thank you again. If you have any questions, just let us know, guys.
I had a question.
Yep.
So you're recording this. How is this accessible to us?
I'm going to just upload it to YouTube so you can browse it from whatever device you have.
So you'll send it via an email?
Yeah, I will send an email. Yeah.
And in terms of accessing this shared development space, is that going to end as soon as this is done?
No, but no. Thank you for reminding me about it. There is. I'm going to. Where is it? 1 second. There is this workspace. The Cloud9 workspace has a GitHub repo associated. So 1 second. This repo that it doesn't have anything now, but I'm going to push the code to that repo later in case you want to check it out and use it by yourself in your computer. Okay, guys, thank you all for being here. Let us know if you have any other questions.
Thank you very much.
Thank you.
Thanks, Santiago.
Bye.
Thank you so much. Thank you.